I have to start today's deep dive with confession.
Oh.
I am a complete digital hoarder. I mean, I have thousands of text files, markdown notes, random code snippets.
You know, that is probably the most relatable confession in the tech world. We all have that junk
It's
drawer.
digital junk drawer, exactly. And it's buried in folder structures I created maybe 3 years ago and have totally forgotten about.
It's that archives folder that you swear, one day I'll organize this. But that day never comes. It just grows into this, impenetrable black hole of information.
It's the digital amnesia that gets me. I know I wrote a note about some specific API configuration. I can almost picture the bullet points.
Right.
But was it in notes.md? Was it for GGUF.txt? Did I save it last year or last week? I have absolutely no idea.
And that's when you start the frantic grep command, just hoping you get lucky with a keyword.
Yes. And you either get 0 results because you used the wrong word, or you get, 5,000 results for something generic like config.
It's a mess.
It's a nightmare. But today, we are diving into a tool that claims to solve this specific kind of panic. It's a GitHub repository by a developer named Toby called QMD.
Query Markup Documents.
And the promise here isn't just better search. It's effectively building a private, state-of-the-art search engine for your own brain. And it all runs locally.
That local part is really the headline for me. I mean, we're seeing this huge explosion in AI search tools right now. Perplexity, all the others, but they all work the same way.
You send me data?
You give them your data, they process it on some massive server farm, and they give you an answer. QMD is interesting because it just flips that whole model. It says, no, we can do the heavy lifting right here on your laptop.
So the mission for this deep dive is to figure out how it actually pulls that off. We're going to look at the architecture of what they call a hybrid search pipeline and try to understand how this all connects to the future of AI agents.
Sounds good.
But let's start with the basics. If I uninstall this thing right now, what am I even looking at?
Visually, not much. It's a command line interface, a CLI. It's built for people who live in the terminal.
No shiny dashboard.
No shiny dashboard, no animations. Under the hood, it's running on the Bun runtime, which is all about speed, and it uses SQLite for the database.
So it's pretty low overhead. It's not going to eat up 4 gigs of RAM just sitting.
Extremely low overhead, yeah, at least until you kick off the AI processing. But the magic is really in how it treats your files. It's looking at Markdown, text files, transcripts, but it doesn't just read them, it ingests them.
Into a local AI model setup.
Exactly. It uses Node Llama Stack Queue to run something called GGUF models.
Okay, let's pause on the acronyms for a second. GGUF.
Right, yeah. It stands for GPT-Generated Unified Format. Basically, it's just a file format that lets these really large language models run efficiently on normal consumer hardware.
Like my MacBook.
Like your MacBook or a decent Windows laptop, yeah. You don't need a massive server GPU. It quantizes the model, compresses it so it fits in your RAM.
So it's bringing the brain down to the size of the device. Now, one feature in the setup caught my eye because it felt curiously manual. The QMD context add command. If this thing is so smart, why do I have to manually tell it what my folders are?
That's a great question because it gets at a huge limitation of AI that people forget. AI is great at reading text, but it's terrible at understanding intent without any cues.
Give me an example.
Okay, let's say you search for the word deployment. If QMD finds that word in your, say, personal journal folder, it might mean a military deployment or something metaphorical, right?
Sure.
But if it finds deployment in your work docs folder, it almost certainly means shipping code to a server.
Right. Same word, totally different universe of meaning.
Exactly. So by using QMD context add, you're giving the search engine a map before it starts. You tag notes as personal thoughts and dev as technical documentation.
That's like telling a librarian, I'm looking for books on apples, but the computer company, not the fruit.
Precisely. You're setting boundaries so the AI doesn't hallucinate relevance.
Okay, so we've got the files index, context is set. Now for the search itself. The docs make a huge deal about this being a hybrid search pipeline. Why do we need a whole pipeline? Why can't I just use grep?
Because grep is, well, for lack of a better word, dumb. Or technically it's brittle. Standard search uses something called BM25, or full text search. It matches characters, you search for login, it finds login.
But if I wrote authentication in my notes, grep files.
Fails completely. You missed the file because you didn't guess the exact synonym you used 3 months ago. So the industry fixed this with vector search.
Right.
This turns your text into long lists of numbers vectors that represent the meaning of the text. So in that vector space, login and authentication are sitting right next to each other.
Problem solved then. The machine understands the vibe.
Well, now you've got the opposite problem. A vector search can be too fuzzy. You search for apple, and it gives you results about oranges because they're both fruits, but it might miss the specific file about the Apple iPhone.
So keyword search is too precise and misses concepts. Vector search is too conceptual and misses specifics.
And that is exactly why QMD uses the hybrid approach. It doesn't choose one. It runs both. It uses FTS5 for the keywords and cosine distance for the vectors, all at the same time.
But that's just the retrieval layer. The part that really surprised me was that there's a third layer. It doesn't just find the files. It judges them.
Yes, this is the LLM re-ranking. This is what makes it SOTA state-of-the-art.
So walk me through that. How does the judging happen?
Okay, so QMD uses a specific local model embedding Gemma 300M to create the vectors. That's a Google model. But once it pulls a list of, say, 50 potential results, it passes them to another model.
A different one.
Qwen3 re-ranker-0.6b. And this model's only job is to look at your query, look at the chunk of text, and score how relevant it actually is.
It's like having a little assistant quickly read the 50 documents and go, nope, nope, yes, definitely not yes.
Exactly. And it does this locally, but it gets even crazier. Before any of that, QMD does something called query expansion.
I saw this in the logs. I typed quarterly planning, and the system searches for like 3 different things.
Right. It uses a 1.7 billion parameter model that's fine-tuned just for this. You type quarterly planning. The AI thinks, okay, he might have also called this Q4 roadmap or OKRs or business strategy.
It's guessing my synonyms before I even think of them.
It generates 2 alternative queries. Then it searches for your original query, which it gives double weight to, plus the 2 AI-generated ones. And it runs the keyword search and the vector search on all 3.
Whoa, that is a massive amount of crunching for one simple request.
It is. You potentially have 6 different lists of results coming back. And this brings us to the hardest part of search engineering. How do you combine those lists?
If keyword search says file A is number 1, but vector search says file B is number 1, who wins?
Exactly. The documentation mentions something called RRF, reciprocal rank fusion.
Yeah, that sounds like something from a nuclear physics paper.
It sounds scary, but the logic is actually really elegant. RRF is just a formula to merge rank lists. The core idea is that being at the top of any list matters a lot. Being at the bottom matters very little.
So it's like a consensus mechanism.
Yeah.
If both the keyword and vector searches agree a file is relevant, it shoots to the top.
Yes. But QMD adds this little bit of secret sauce that I absolutely love. It's called the top rank bonus.
I saw that. It adds a flat 0.05 score bonus if a result is number 1 in any list.
Right. And think about why. If you search for a specific file name, like budget2024.md, the keyword search will find that instantly. Rank 1.
For sure.
But the vector search might get confused and put it at like rank 20. Without that bonus, the vector search could drag the score down. The bonus ensures that if one method is absolutely certain its voice gets heard.
It respects the exact match. That's smart.
But the real aha moment for me, the part that shows the developer really gets it, was the position-aware blending.
Okay, this was the 7-25 split versus the 40-60. I had to read that part twice.
It's so clever. The system changes who it trusts based on how good the results are. If a document lands in ranks 1 through 3, the very top, the final score is 75% from the retrieval score, the search math, and only 25% from the re-ranker AI.
So for the top results, we trust the hard math. We trust the keywords.
Right. The assumption is, if it's at the top, it's there for a reason. Don't let the AI overthink it. But if a result is way down the list, rank 11 or lower, the ratio flips.
It becomes 40% retrieval, 60% re-ranker.
Why do you think it flips?
I guess. Because down at rank 11, the signals are weak.
Exactly. The keywords are vague, the vectors are fuzzy. At that point, you need the AI's intelligence to look at the text and say, actually, despite the low math score, this paragraph is exactly what the user is asking for.
That is fascinating. So it uses the dumb search for the obvious stuff and the smart search for the ambiguous stuff.
It's a brilliant way to balance speed and accuracy, and it prevents the AI from just making things up at the top of the list, which is a huge problem in pure vector search systems.
Okay, so we've been talking about this as a tool for a human. I type a query, I get a result. But the documentation explicitly mentions agentic flows.
The buzzword of the year.
What does a local search engine have to do with agents?
Well, QMD isn't just for you. It's designed to be the long-term memory for other AIs. It has an MCP server built right in.
MCP.
Model Context Protocol. It's a standard that lets an AI model, like Claude on your desktop, talk to your local tools.
So instead of me typing QMD query in my terminal, I could open Claude and just say what?
You could say, Claude, look at my notes from last week and draft a follow-up email to the team. Claude doesn't have your notes. It can't access your hard drive normally.
Right.
But if QMD is connected via MCP, Claude can silently query QMD, pull the relevant files, read them, and then write the email for you.
So it gives the chatbot a photographic memory of my hard drive.
But without uploading your hard drive, that's the critical part. The data retrieval all happens locally. Claude only ever sees the specific snippets it needs to answer the question. It's a privacy firewall.
And to make that fast, the docs mention running it as a daemon.
QMD, MCP, HTTP daemon. Yeah. If you don't do that, every time you ask a question, your computer has to load those GGUF models into VRAM.
Which takes a few seconds.
It takes a few seconds, maybe 5 or 10, depending on your machine. It feels sluggish. Running it as a daemon just keeps the brain loaded in memory, ready to fire instantly.
Like keeping the car engine running so you can just take off.
Exactly.
Yeah.
And it supports other cool things like QMD multi-get. You can use glob patterns.
Glob patterns.
Wildcards. So you can say, get me journals 2025-05.md. It'll pull every file from May 2025.
Wow.
And you can feed that whole chunk of context to an agent and say, analyze my mood for the month of May.
That is powerful. And also slightly terrifying if you haven't been honest with yourself in your journal.
Well, that's between you and your local LLM.
So speaking of the practical side,
Yeah.
say I'm sold on this. I want to install it. Is it complicated?
If you have Bun installed, it's literally one line. Bun install -g github.tobyqmd. It even handles the model downloads for you the first time you run it.
And when I run a search, how do I know if the results are actually any good? Does it give a confidence score?
It does, and it color codes them, which is really intuitive. Scores from 0.8 to 1.0 show up in green. That's a high confidence match.
And low scores?
0.0 to 0.2 is just dim text. It's like a heat map for relevance. You can quickly scan and see, okay, the first 3 are green, the rest are probably garbage.
There was one last technical detail I wanted to ask about, the chunking. It says it chunks documents into 800 tokens with a 15% overlap. Why the overlap?
Imagine you're reading a book, but you have to tear the pages out to file them. If a really important sentence starts at the very bottom of page 10 and ends at the top of page 11.
And you tear them apart, you lose the meaning of that sentence.
You lose the context completely. Neither page contains the full thought, so the search engine would never find it.
So the overlap is like photocopying the bottom of one page onto the top of the next one.
Exactly. It just ensures that no concept gets severed because it happened to fall on a structural boundary. It maintains the semantic integrity of the text.
It's those little details, the overlap, the ranking bonus, the position-aware blending, that really seem to separate this from just some weekend project.
It's extremely thoughtful engineering. It acknowledges that search is messy and, human memory is flawed. It's trying to compensate for our bad organization with raw compute power.
So zooming out, we have this tool that runs locally, respects your privacy, and uses these SOTA models to understand not just what we wrote, but what we meant. What's the big takeaway here?
I think QMD represents a real shift in personal knowledge management. For decades, we've been obsessed with folders. We organize, we tag, we create these elaborate systems for our own files because we're terrified of losing them.
We organize to compensate for bad search. I spend half my life moving files into archive folders just so my main folder looks clean.
And QMD suggests maybe we don't need to do that anymore. If the retrieval is this good, if the vector soup is smart enough, you can just dump everything into one folder. The machine will find the connection better than you ever could.
That's a liberating thought. The end of the folder hierarchy.
And on a technical level, it really highlights the rise of SLM small language models. We used to think you needed a massive data center to do this kind of semantic understanding. Now we know you can do it on a MacBook Air with a quantized model. That's a huge democratization of intelligence.
So here's a final thought for you to take away. If you can query your entire digital life with the precision of an LLM, but without the privacy risk of the cloud, does that change what you write down? If you knew your computer could actually connect the dots between some random thought you had 3 years ago and a project you're starting today, would you treat your notes less like a junk drawer and more like a data set?
That was the question.
Maybe we should all start writing for the AI that will eventually read our notes. Thanks for diving in with us.
My pleasure.